Hello, today I will be discussing about some problems of matrix. Okay, so here is the problem. This is the matrix, and this is the problem. It means the left hand side is equal to 0. We have to prove it, and we have to find out A inverse. So let's begin. This is the solution. We start from here. This is the solution. So now this is the matrix and A. So A square means A multiplied with A. So here A matrix, here also a matrix. And we multiply the first row with the first column to get the first element of the A11 element of A square matrix. So we get this element by multiplying this row with this column. Okay, so 5 multiplied with 5 plus 4 multiplied with 4 plus minus 2 multiplied with minus 2. This is the element. Again, first row, second column, we get 5 multiplied with 4 plus 4 multiplied with 5 plus minus 2 multiplied with minus 2. This element. Now, first row, third column. So 5 multiplied with minus 2 plus 4 multiplied with minus 2 multiplied with plus 2. So we get this element. In this way, we get all the elements, all the 9 elements. Okay. Now, for example, suppose we have to find out this element of the A square matrix. So we have to multiply second row with first column, 4 multiplied with 5 plus 5 multiplied with 4 plus minus 2 multiplied with minus 2. So we get this element. And in this way, we will find out all these elements of A square matrix. Now making simple addition, we get 45, 44 minus 22, 44, 45 minus 22, minus 22, minus 22, 12. So this is the value of A square. Okay. Now we have to find out the 11. We have find out A square. We have found out A square, and now we will find out the 11. So 11 multiplied with the matrix. Okay. So A 45, 44 minus 22. So where is A? This is the A element, and A 5, 4 minus 2, 4, 5 minus 2, minus 2, minus 2. So 11. And we get multiplying each element with 11, we get this. Now we have to find out 10A. 10A. 10, we have to find 10I. So 10I equal to I is the identity matrix. 10 multiplied with the identity matrix, we get the 10 along the diagonal. So now A square minus 11A plus 10A, just putting the values, we get this. Here is the simple addition. 45 minus 55 plus 10 would be the first element of this matrix. Look, now I am using all this marking. Okay. Now I am using all this marking. Look, in this way, getting simple addition, we get these elements, these 9 elements. Now, after simplification, we get 0, 0, 0. 45 minus 55 plus 10 equal to 0. 44 minus 44 plus 0 equal to 0. So minus 22 plus 20 plus 0 equal to 0. So all the elements are 0 in this way. So we have proved that A square minus 11A plus 10I equal to 0. Now, from this equation, we get A dot A minus 11IA plus 10I equal to 0. It is known to us that it is known to us that any matrix multiplied with the identity matrix will get the same matrix. Okay, so A minus 11I equal to A equal to minus 10I. We just take A as a common factor, we get A minus 11I equal to minus 10I. So minus now it is known to us that A inverse multiplied with A equal to identity matrix. Okay, A inverse multiplied with A is the identity matrix. So look, minus 10 minus 1 by 10 A minus 11I multiplied with A equal to I. At first we have shift minus 10 to the left side, and we get simply I equal to minus 1 by 10 A minus 11 multiplied with identity matrix dot. Now as A inverse multiplied with A is equal to I multiplied with A is equal to I. So A inverse equal to minus 1 by 10 A minus 11I. A minus 11I. A minus 11I. Okay. So now we put the values of A and I identity matrix here. So 5, 4, minus 2 is the element of the A matrix, and this is the identity matrix. And now just multiplying 11 with each element, and this is the situation. Now 5, this is the subtraction of matrix. So 5 minus 11, 4 minus 10, 5 minus 11, 4 minus 0, minus 2 minus 0, 4 minus 0, 5 minus 11, minus 2 minus 0, minus 2 minus 0, okay, minus 2 minus 0, okay, 2 minus 11. So 1 by minus 10, after simplification, we get this. Now we divide minus 6 with minus 2, we get 3. Okay, and 4 minus 2, we get minus 2, and 10 minus 2, we get 5. So in this way we simplify this. In this way simplify this, and we get this. So this is nothing but the A inverse. This is nothing but the A inverse. So we have proved that A square equal to minus 11A plus 10I equal to 0. A inverse equal to 1 by 5 this. So we have proved it. Now another problem. Here is another problem. A inverse is given. This is the matrix. A inverse is given, and we have to find out it. So this is the solution. Look, A inverse is this matrix. It is assumed that it is B. Now we have to find out the determinant of the B matrix. So determinant of B is nothing but within the determinant symbol, we put the elements of the matrix, and now we find out the determinant. This is 2 multiplied with the remaining part. We strike off this column. What remains? 1, 2, 2 minus 1, 1 2 2 minus 1. Now minus 5 5 5 multiplied with the matrix, we cancel out this column and this row. Okay, then there remain what remains 3 2 1 minus 1, 3 2 1 minus 1. Now plus 3 plus 3, this we cancel out this column, this row, 3 1 1 2, 3 1 1 2. Okay, and in this way we find out the determinant. And after simplification, because 2 multiplied with 1 minus 1, 1 minus 1 minus 2 multiplied with 2, 2 multiplied with 2, minus 5 minus 5, 2 multiplied with minus 1, and minus 2 with 1 multiplied with 1. So in this way we have find out simplified this determinant, and we have found that the determinant is 30, it is not equal to 0, so B inverse exists. So B inverse exists. So this is the B inverse. So we have to now we have to find out the B inverse. B inverse is nothing but the ratio of adjoint B and determinant of B. So if we divide the adjoint B with the determinant B, we get the B inverse. Now, what is the procedure to find out the adjoint B? So this is the B matrix, and now we find out the cofactor of this matrix. And in the same way, in my previous lecture, I have shown that how to find out the cofactors. So 2 is the cofactor of 2 is nothing but 1 2 2 minus 1. We have cancelled out this column, this row. What remains this? So this is the first element. And cofactor of 5, cofactor, we cancelled out this row, this column. What remains? 3 2 1 minus 1, 3 2 1 minus 1. And here is plus, here is minus. Again, cofactor of 3, we cancel out this column, this row, 3 1 1 2, 3 1 1 2. Okay, so the sign will be changing in this way: plus minus plus minus plus minus plus minus plus. Okay, in this way. So we have to find out the cofactor. Now adjoint B is the transpose of the cofactors of matrix B. So there is a transpose sign. This is the transpose sign. This is the transpose sign. And after simplification, we get minus 5 11 7, 5 minus 5 5, 5 1 minus 13, and transpose sign is there. And then we transpose, that means columns will be converted into rows, and rows will be converted into columns. So minus 5 plus 5 is the row, it will be the column. So minus 5 5 5. 11 minus 5 minus 2 is the row, it will be the column. So 11 minus 5 1. 7 5 minus 3 is the row, it will be the column. So 7 5 minus 30. So we have made the transpose. So B inverse is equal to adjoint B by determinant of B. The adjoint B is nothing but this. So this is the adjoint B and this is the determinant. So we have found out the B inverse. Okay. Now B inverse is this. Okay, we have found out it, and now B inverse is equal to A inverse and its inverse. Inverse of A inverse is the B inverse. Okay, since B is the A inverse, so then B inverse is the inverse of A inverse. So inverse of A inverse is A. Inverse of A inverse is A. Okay, so A equal to 1 by 30 and this element 1 by 30 and 1 by 30 and these elements. Okay, so we have found out the A matrix. Find out the A matrix. Now another problem. Now look, here is the A inverse is given, and we have to find out the A. The solution starts from here. Okay, so A inverse equal to 1 by 4, 30 minus 57, and after multi after multiplication each element by 1 by 4, we get this matrix, and it is considered as B matrix. Now determinant of B is this with this symbol, determinant symbol, and equal to, because 3 4 multiplied with 7 4 and 0 minus 5 4. Okay, so this is the determinant. We have to multiply this element with this element and minus 0 with this element. So ultimately we get this 21 by 16. It is not equal to 0. So B inverse it is. So we have to find out the B. We can find out the B inverse, and B inverse can be found out by dividing adjoint B with determinant of B. And in my previous slide, we have shown that how to find out the adjoint B. And by transposing the cofactors of B matrix, we get the adjoint B. So in the same way, we find out the cofactors of these elements, and transposing the matrix, we get the adjoint B. So look at this. So these are the elements. So cofactor is the cofactor of 3 by 4 is 7 by 4. So 7 by 4. Cofactor is minus 5 by 4 equal to 0. So 0. And the cofactor of 0 is minus 5 by 4. So minus 5 by 4, and minus sign is there because there is a rule, plus minus plus minus. So 7 by 4, the cofactor of 7 by 4 is 3 by 4. Okay. So in this way, we have found out the cofactors. Now transpose. There is the transpose sign, and we transpose it, and the columns will be converted into row. These are the columns, and it will be converted into row. So 7 by 4, 5 by minus 5 by 4 is the row. 7 by 4. Sorry, this minus will be cancelled out. So 7 by 4, 5 by 4 will be the row, and 0 and 3 by 4 will be the second row. So now, after taking 1 by 4 out of the matrix, we get 1 by 4, 7503. So now this is the adjoint of B. Now B inverse equal to 1 by determinant B equal to adjoint B equal to 1 by B, determinant is 16 by 21 dot adjoint B. 16 by 20, and after simplification we get this. So B inverse, it is as A inverse equal to B, so B inverse is nothing but the inverse of A inverse. B inverse is nothing but the inverse of A inverse. Now A equal to since A equal to 4 by 21, 7503. So now we can prove that A multiplied with A inverse equal to A inverse A equal to identity matrix. A inverse A equal to A inverse A. Look, A inverse A. So this is the 421 A 7503 is the A. A inverse is 1 by 4, 30 minus 5 by 4, and we can find out the A inverse by the same procedure as the adjoint, by dividing the adjoint A with the determinant of A. So we get this. Okay, we get this, and after simplification, the procedure of the multiplication, following the procedure of the multiplication, we get this element. We get this element. How? This is the first row. This is the first column. So 7 multiplied with 3 plus 5 multiplied with 0. Again, this is the first row, second column. First row 7 multiplied with minus 5 and 5 multiplied with 7. Again, this is the second row, first column. Second row 0 multiplied with 3 plus 3 multiplied with 0. Second row 0 multiplied minus 5, 3 multiplied 7. So this element. After simplification, we get I. This is the identity matrix. So A inverse A equal to identity matrix. Okay, A inverse A equal to identity matrix. So it is proved. Thank you for enjoying these lectures on matrix, and we have solved some problems of matrix. Hope you have enjoyed it and you have understood the problem. Thank you. Thank you for enjoying my lecture. Thank you very much.